Hi everyone, welcome to Snowflake again. In this video, we are going to look into a virtual warehouse. So, virtual warehouse is an important part in the complete Snowflake architecture. So, this is going to be a quite lengthy topic. So, please plan to spend at least 10 to 20 minutes with this video. So, a virtual warehouse. So, a virtual warehouse, simply call it as warehouse. You can see with a single cluster or with a multi-cluster virtual warehouse. So we will be looking into multi-cluster warehouse in the coming videos. So if you think about a warehouse, it is nothing but a server. So it is nothing but a server which will do work for your queries or for your request. So if you see here, so this has CPU memory, temporary storage to perform all these topics. So if you see here, your virtual warehouse is capable of doing your select statement, your DML statements like delete, insert, update. Similarly, it can do a data load into the Snowflake tables. Similarly, it will do unloading data from tables in the Snowflake to the external stages. So all these operations will be performed using these virtual warehouses. So if you see here, you can create an individual virtual warehouses based on your requirement. So suppose if you are querying a very less data, then you can go for a small warehouse and you can configure for that particular group so that this group will be using only that particular warehouse. Suppose if there is a particular group who are reporting, who are querying huge data, so in that case, you need to create a separate big virtual warehouse and you need to assign to that particular group. So based on the requirements of each group, you can create a separate warehouses and you can assign it to them. So in that way, you are not going to waste the credits of the virtual warehouse. Similarly, you will get a virtual warehouses in different sizes starting from extra small to 4x large. So the servers in each virtual warehouse define the size of the virtual warehouse. Suppose if your virtual warehouse cluster has one server, it is defined as small, extra small, sorry. If your cluster has two servers, it is defined as small. Got it? See here? So the number of servers in each cluster defines the size of your virtual warehouse. So based on the servers in your virtual warehouse will define your credit as well. So it's all directly proportional. See here, if you have one server, you will be using charged with 1 credit per hour. If your cluster has 2 servers, you will be charged with 2 credits per hour. Similarly, if you have four servers, you will be charged with 4 credits per hour. Similarly, if your cluster has 128 servers, you will be charged with 128 credits per hour. So, for a 4x, if you are running a 4x large virtual warehouse, per hour you will be charged with 128 credits. So this is how you need to plan while creating the virtual warehouse based on your requirement. If your requirement demands only the small warehouse, then better go for a small warehouse, and so that you will be charged only 2 credits. You will be charged only with 2 credits per hour. Okay, so while creating a virtual warehouse using a create warehouse command, if you don't give any warehouse size, automatically you will be provisioned with a extra small warehouse size. warehouse. Similarly, if you are creating using a web GUI interface, so you will be created with an extra large warehouse as a default. It's a default warehouse. Okay. So this is how you need to plan while choosing the size of your virtual warehouse, because your virtual warehouse size is directly proportional to your servers and credits. So whatever warehouse size you choose, you will be charged with those credits. So more the servers, so the size will be increasing. Consider the extra small, it has only one server. So suppose now you are using an extra small virtual warehouse, and if your query performance is not that good, and it is not capable of processing the data, then you can resize your warehouse and move on to size small. So because the small virtual warehouse has two servers, so now the two servers are capable of doing your work. So that's the reason your query performance will increase when you jump onto the next virtual warehouse, because the compute resources, everything will be more compared to the lower virtual warehouse. So coming to the size and credits, see, Snowflake charges based on a 60 seconds minimum billing, that is 1 minute minimum billing. Suppose if you use a warehouse between 0 to 60 seconds, you will be charged with the same credits. So if you see this chart, so 0 to 60 seconds, I am charged with the same credits. Whereas from starting from 61 seconds, you will be charged like per second. Still 60 seconds, you will be charged with 0.017 seconds. Whereas after uh, 60, it is your additionally you have used 1 second. So you will be charged with this 1 second. Okay, so that is per second billing. So, because you might have started your virtual warehouse, but your virtual warehouse have suspended before completing 1 minute. In that case, you will be charged the complete 1 minute credits. Whereas after 1 minute, whenever you have your virtual warehouse has suspended, you will be charged with those many seconds. Okay. So coming to multi-cluster architecture. So multi-cluster architecture is nothing but provisioning the virtual warehouse with multiple clusters. So far we have seen the virtual warehouse with only one cluster. So creating one cluster with different sizes. But here, if you see, you can create a virtual warehouse with multi-cluster. So this come, uh, one second. So this, if you see here, this is a completely one virtual warehouse. It has multiple cluster 1, cluster 2, cluster 3. So you should make a note here. So your cluster, all suppose if you have created a warehouse with multi-cluster, all your clusters will have the same virtual warehouse size. Okay. So suppose if you have created virtual warehouse with medium size, so the medium size has 4 servers, right? So the cluster will be created with will be created with medium sized servers, and whereas the cluster 2 will be created with medium size servers, whereas cluster 3 also will be created medium size. So totally we have 4 here, 4 here, so 4 here. So now your virtual warehouse, which is having 3 clusters, totally has 12 servers. So now your virtual warehouse is capable of handling the huge loads. Let us see how it differs. See, by default, a virtual warehouse consists of a single cluster of servers. That is what we have seen in the previous slides. So the total resources available to the warehouse for executing queries. So as queries are submitted to a warehouse, the warehouse allocates the resources to each query. So suppose the query 1 came. So it calculates how much resource does the query 1 requires. So it will allocate from the cluster. So this much resource. When the next query comes, it will allocate again that much resource. Suppose all your resource is completed from the virtual warehouse, and again there is one more virtual queries has come in. So if sufficient resources are not available to execute all the queries submitted to the warehouse, Snowflake queues the additional queries. So what it will do, until the resources are freed up, the additional queries are queued up. So it will be waiting for the resources. So that is what happened in a single cluster. So this queries has to wait until the resource is available. So coming to multi-cluster warehouse, Snowflake supports allocating either statically or dynamically. So initially itself you can allocate these many resources to handle the queries, or you can make these cluster available dynamically. That is how we will see now. So I mean a large pool of resource to each warehouse. That's what we have allocated 3 clusters. So each cluster will have, if you consider medium size, each cluster will have 4 servers. So this will be created giving maximum number of server clusters and minimum number of server clusters. So these parameters is used for auto scaling purpose. So if you tell maximum number of server clusters, if you tell 3, so you will be created with 3 clusters. Similarly, minimum number of clusters, in the sense that this is helpful in the auto scaling. Suppose, consider in a peak hour there are more users coming and more queries are coming in. That time you have to handle more traffic. So that time you can tell it has to handle more queries. Based on the queries coming in, the new clusters has to be available. So initially it will be running with one cluster. Sorry. Initially it will be running with one cluster. So when the additional load is coming in, the other clusters will automatically will be started, and it will be capable of handling the additional load. So once this additional load is dropped off, automatically these additional clusters also will go into the suspended mode. So if your incoming load is if this the single cluster is capable of handling the existing load, so the only this will be available for the users. So this is how the multi-cluster architecture helps in handling the load in a different circumstances. So see here, the multi-cluster warehouse is nothing but it is similar to the single cluster warehouse and is capable of doing the same activity what the single cluster do. You can specify the size of the warehouse. That's what, as I said earlier. So if you define this as a medium-sized cluster, medium-sized virtual warehouse, so all clusters will be defined as a medium size. The same size will be applicable to all the clusters. Okay. Similarly, you can resize at any time. So initially you thought I need to create this virtual warehouse as a small. So later you decided, so this is not sufficient for me, so you can resize this complete clusters virtual warehouse is medium. Similarly, auto suspending a running warehouse due to inactivity. So note that this does not apply to individual clusters but rather the entire warehouse. So what you will do, you will be auto suspending a running warehouse. So this complete warehouse, which is a multi-cluster warehouse, you can suspend it. You want to suspend the complete virtual warehouse, if that is what I'm telling. So if this complete clusters is not handling any queries and nothing load is coming in, then the complete cluster, the complete virtual warehouse which has these many clusters completely will go into the suspend mode. If suppose a less data is coming up, and this cluster is still handling those queries, then your virtual warehouse will be running, but this virtual warehouse will be only the will have only one cluster running, the other clusters will be in the sleep mode. Okay, so auto resuming as suspended warehouse. So once your virtual warehouse is in resume state, when there is a new query coming in, definitely the virtual warehouse will start up automatically. So now we have learned about multi-cluster, right? There are two kind of options in the multi-cluster, that is maximized multi-cluster and auto-scale multi-cluster. Okay, so what is the difference in instance? So auto-scale, the name itself, it is telling, right? So whenever there is a load, there is a peak load, so that time I need the additional clusters to be started and start handling the additional load. So whenever these loads are finished up, I want this additional clusters to be stopped. So this is called auto scaling. So it will grow when there is a peak load and it will shrink automatically when there is no load, when there is very less load. If the coming data can be handled with only one cluster, so other clusters will be automatically stopped. If there is a huge load coming in, then the new clusters will start up. So this is called auto scaling option. Similarly, what is maximized? So maximized option in the sense you consider that your application is completely used with the maximum users all the time. So you know all the time everyone will be using it. So then you will create this cluster within a maximized mode. In the sense, these all clusters will be up and running all the time and will be available for the users to perform the query operations. So you should keep in a mind while going for a maximized, because in a maximized option you will be charged more credits compared to the auto scale mode that we will see in the next slide. So there are different policies available for the auto scale mode. So these policies are available only when you are running the multi-cluster in an auto scale mode. So this is not applicable for the maximized mode. Got it? So how these policies are going to make benefit to the customers? So these policy modes are completely defined to control the start and shutdown of the clusters. As I said earlier, so this auto scale, this multi-cluster in an auto scale mode can help you in growing or in creating the new clusters when there is a huge load, and shrinking up your clusters when there is a less load by avoiding the queuing method, by avoiding the queries queuing policy. Okay, see, let us see how. So we have, as said, we have two policies. One is standard policy and one is economy policy. So in a standard policy, This minimizes the queuing by favoring the starting additional clusters over conserving credits. So in the sense, so it this if you define your multi-cluster in an auto scale mode with a standard policies, it will avoid the query queuing time. So by creating the new clusters, so definitely if you are creating a new clusters, there is an additional credits also will be charged on you. So but you will be reducing the query queuing time. So how this happens? So when the warehouse sees there is a query waiting for the resource, it will immediately go and creates a additional cluster. See here, immediately when either a query is queued or the system detects that there is one more query than the currently running queries. Okay, so in the sense, so if it detects if there is a new query is queued up, or if it detects a query that cannot be handled by the existing cluster, then immediately it will go and spins up the new cluster. So it will redirect those queues or queries to the new cluster, and you will work will be done with the new cluster. So this is how it is. This is the condition based on which your new clusters will start up in the standard mode, and how it will get shut down. So it will keep on checking after 2 to 3 consecutive successful checks in a 1 minute interval. For every 1 minute interval, it will check 2 to 3 times. It will check so whether there is no load on the any of the clusters. So in that check, if it finds if there is very least load could be redistributed to other cluster. So if there is a least, consider you have 3 clusters and your third clusters, when it is consecutively checking your third load, your third cluster has very minimal load, and that load can be redistributed to the rest of the 2 clusters. So then what it will do, it will redistribute its loads to the rest of the cluster, and it will shut down, it will bring down your third cluster. So in that way you are saving the credits. So coming to the economy mode, so the name itself, it will say, it will tells that you are going to save some credits with this economy mode. So but there is a there is a downside in this, is your queries will be queued up because you are saving the credits here. Definitely there will be a downside, like you are going to queue up your queries. See, conserves credits by favoring keeping the running cluster fully loaded. So it will make the complete class the existing clusters in a full load. So rather than spinning up the other clusters and getting charged back the credits. So but it will wait. Existing clusters are, if the existing clusters are completely loaded and the new and the new queries has came up, it will not immediately spins the new clusters, because see here, because on based on these conditions, only if the system estimates there is enough query load to keep the cluster busy for the at least 6 minutes. See, there is a low. Suppose there is a new query came in, and the existing 2 clusters are not capable of handling this new query. Then it will make that query to queued up, and it has to wait, because this one new query cannot make the new cluster to be completely loaded for the 6 minutes. If the new load is capable of keeping the new cluster completely busy for at least 6 minutes, then only the system is going to spin up the new cluster. Until that condition is met, it will not spin the new cluster, so that the existing queries has to be queued up. Okay, sorry. So this is how. So let us see when in this mode, when this cluster go down or shut downs. Similarly to the standard mode, here for every in one period, 1 minute of interval, it will check 5 to 6 times consecutively whether there is a minimal load on the cluster. If it finds there is a minimal load and it can be redistributed to the other clusters, so it will redistributes the load to the other clusters and it will shut down the cluster. Okay, sorry, 1 second. This okay. So next we will see the multi-cluster size and credits usage, how these are how the size is impacted and how the credits usage will be. So if you see here, the total number of servers of the warehouse is calculated by multiplying the warehouse size by maximum number of clusters. So consider in a single cluster, which is a warehouse which is a single cluster with extra small. So in that case, your single cluster will have only one server. So you will be charged with 1 credit per hour. Okay, if it is a single cluster created with small size, then you will be charged with, you have two servers, right? So yours is a you'll be charged with 2 credits per hour. Similarly, in a multi-cluster environment, consider you created this warehouse. This is a multi-cluster warehouse with medium size. So then, how many credits you will be charged for 1 hour? So medium has 4 servers. So this cluster has 4 servers. This cluster has 4 servers. This cluster has 4 servers. If you see here, medium size has 4 servers. So totally you will be charged with 12 credits per hour. So this is how you need to calculate. So if you see here, it is 12 credits. So if a multi-cluster warehouse is resized, the new size applies to all the clusters of the warehouse, including the clusters that are currently running and any cluster that are started after the warehouse is resized. So consider you have created this warehouse with small and you somehow thought this is not handling your load. So then you have resized it to medium. So this new warehouse size is applicable to the complete all the clusters. Got it? So and you will be charged based on this medium, not based on the earlier size. You are be charged with based on the new size. Let us see the benefits of a multi-cluster warehouse. So in a single warehouse, suppose you are running with a particular warehouse, considers yes. Suppose if there is an additional load and it is not capable of cannot be handled with the existing small warehouse size, so what you have to do, you have to start additional warehouse. Consider with you create a new warehouse of medium size and explicitly redirect additional users or query to this warehouse. So you have to manually create a new warehouse and you need to redirect all the new loads or new queries to the new warehouse. So consider now the resource has been gone. So now your business is usual. There is a very less load. What you have to do? Again you need to again you need to either create again a small warehouse and redirect your traffic to the small warehouse. Otherwise, if you don't do that, the more credits will be conserved. Okay. So coming to the multi-cluster warehouse, this is completely handled automatically with auto scale mode. In an auto scale mode, as we have discussed earlier, if there is an additional load coming in, the new clusters will be spinned up automatically. Okay. If the additional load is completed, your additional clusters also will be shut down automatically. So this is the reason, that's the reason you will not be charged with the extra credits. Suppose the if you have heavy load all the time, you can create your multi-cluster with a maximized mode. Okay. So this picture will clearly tell you how you can benefit with a maximized mode or auto scale mode. So based on your requirement, you have to go for you have to choose the respective modes. Consider, see, we are taking an example of medium-sized warehouse where you have per server you will have four server per cluster you will have four servers. So you will have four here, we'll have four servers, we'll have four here, and this is a medium size cluster. So if you see here, this is a maximized mode in the sense all the time it will be running with it will be running with all the clusters, that is three clusters. So first hour the cluster 1 will be running which have four servers, cluster 2 will be running which have four servers. So totally you are consuming 12 hours in the first hour, second hour four servers per cluster, four servers. So you'll be charged with 12 credits for the second hour. So totally put together, if you run a medium sized multi-cluster warehouse for 2 hours, you will be in a maximized mode, you will be charged with 24 credits. Okay, you'll be charged with 24 credits. So let us see. So if you have the load, that if your virtual warehouse, all your clusters are capable of handling that much load, then that's fine. That is fine. You run your virtual warehouse in a maximized mode and you will be consuming 24. But in a case where you will not have this much load all the time, then you need to go for auto scale mode where you will be saving more. Consider the first hour only the cluster 1 is running, so you'll be charged only with 4 credits because you don't have that load should be handled with the other clusters. So the next hour cluster 1 is running, cluster 2 is running, and cluster 3 is running. Okay. So see here, you might have doubt why cluster 2 has only 30 was charged with 2 credits, because the cluster 3 runs for 30 minutes during the second hour. So it haven't run for 1 hour, it just ran for only 30 minutes. That's the reason you are charged with only 2 credits. So that's the reason you are charged with 10 credits in the second hour, 4 credits in the first hour. Totally put together, you are charged with only 14 credits compared to 24. So this is how you need to plan in choosing the modes of your multi-cluster. So when you don't know, or when you know that you will not have much load all the time, so better you go for the auto scale mode. When you know that all the time all these clusters might be utilized, then you go for the maximized mode. So let us see how we will create the warehouses. So there are different ways we can create a virtual warehouse. Using web interface, you can go to, web interface, you can go for a warehouse tab and there you can create. So you need to provide all these details to create a warehouse. Okay, so this maximum cluster and minimum cluster is used for how to shrink and how to grow and how to shrink in the auto scale mode. So here you can choose type, whether it is a standard type or economy type. Okay, so if you give minimum one maximum, if you give maximum clusters 1 and minimum clusters 1, you will be provisioned with one cluster. and the size of the warehouse you can give it here, whether it is small or extra large, that you can give it. So the same size will be applicable for all your clusters. Suppose if you want to create three clusters, okay, so you can give minimum cluster as 1 and maximum cluster as 3. So you will be provisioned with 3 clusters. So whenever there is a need, the additional clusters will be spinned up. Whenever there is a no need of whenever there is a no need of additional clusters, the low less loaded clusters will be shut down. So this is how we can create with the, what do you say, from the web interface. Let me show you there. So you should go here, you should create. So here you can provide all the details. As this is a trail version, you are not seeing all the minimum cluster and maximum cluster parameters, but when you go for the original version, you can see all those options. So you should give the name here, just select the size, so auto suspend, so till how much time it has to wait, and then go to the suspended mode, just click finish. So similarly, you can create the warehouse with the create warehouse command. So this is how the command looks like. And these are all the parameters you can see. Warehouse size, you can give it with warehouse underscore size parameter. So maximum clusters you can give, minimum clusters you can give. The scaling policy you can give whether standard or economy. Auto suspend true or false, auto resume true or false. Like all those parameters you can give. And this is per object parameters. So how much time the query has to wait until it get the resource. So what is the statement timeout time? Timeout in seconds. So all those you can give it with these parameters. This is the command line parameter. And this is how the command looks like. Okay. Next, to view the warehouses. So if you want to see what all warehouses created in my account, you can just go to warehouses. So warehouses, see, you can see all your parameters here. Similarly, if you want to do it with the command line, just show warehouses like the name. Or if you just give show warehouses, it will display all the warehouses that you have access in the account. Similarly, if you want to alter warehouses, as we discussed earlier, you have a small warehouse and if you want to resize it to medium, then similarly you can go there, go to the warehouses and just configure. See here, select this. This is in suspended mode. That's the reason it is not. So see, if it is in suspended mode, if I go here, if I run this, started. So here, click here. So click configure. So you can change all the properties of the warehouse here. So similarly, if you want to alter the warehouse at the command line with command line parameters, so you can use this command, alter warehouse name resume. If you want to resume, just now I clicked resume, right? The same thing you can do it with the command. Similarly, if you want to change the warehouse size, you can change with the warehouse size. Thanks for watching this video. Hope you like this video. Please subscribe to Snowflake and like this video. Thank you.